Λοιπόν, καλησπέρα σε όλους. Πιστεύω να ακουγόμαστε καλά. Μου είπαν ότι τα λύσαμε τα θέματα με τον ήχο. Hope you guys are ready for another exciting session. This one is going to be in English. We have some excellent panelists to speak about digital twins, which is an interesting term. Before we delve into the discussion, a round of introductions first. So, starting with Mark Bate from ANSYS.
Yeah, hi everyone. Yeah, so my name is Mark Bate. I'm a product sales specialist with ANSYS, and I help customers position and evaluate the use of digital twins within industry.
Okay. Kai Hackbarth from Bosch.
Right. Yeah, hello everybody. So I'm Kai. I'm Senior Technology Evangelist at Bosch Global Software Technologies. And we help our customers in digitization of their products. So this can be connected tires, but this can also be things like paper machines. And we also help them to build up a sustainable digital thread.
Serafeim Katsikas from METIS CYBERSPACE Technology.
Yes, hello everybody. I am co-founder and CTO of METIS, and METIS is a company well established and a leader in IoT and digital twin for maritime sector.
Tilemachos Matiakis, KENOTOM.
Hello everybody, my name is Tilemachos Matiakis. I would like first of all to thank you for giving me the opportunity to be here and discuss with you in the panel. I am one of the founders of KENOTOM and currently the CTO of the company, among other roles, because we are still not a so big company, let's say. And in KENOTOM we develop embedded systems with focus on the automotive industry. On the automotive industry they are called ECUs, electronic control units, the embedded systems. And they are devices hidden in the vehicle that control and automate some components, let's say the transmission, the gearbox, the motor, and many more things.
Excellent. And I'm very excited to be a moderator of this panel. I'm Sotiris Bantas. I'm Vice President of HETIA. I'm also founder and CEO of Centaur, a company that uses the Internet of Things and a digital twin approach to enabling a sustainable supply chain for agriculture. So I think among ourselves, we cover several bases, if not all the bases, with respect to like the modern uses of digital twin approaches, either envisioned or already in practice. But I think digital twins are a semantically loaded term, right? My suspicion is that people refer to them and mean slightly different things. So perhaps we can start with a round of definitions, because if you would allow me to crack a joke here, it's kind of like teenage sex, right? Everybody's talking about it, everybody thinks everyone else is doing it, but no one really knows how it's done. So, but you know, other than that, what is ANSYS' kind of official definition for a digital twin? Mark, you guys are the simulation leader, right? Yeah. Simulation technology leader. So how does that come into play?
Yeah, it's interesting because, as you said, digital twin just can be many things to many people depending on the industry or who you're talking with. But for us, digital twin is a virtual representation of a connected physical asset or process, which can be calibrated at specified intervals and fidelity. That's
amazing. Yeah, I like it.
Plain, yeah.
Concise and gets the message across.
Yeah.
Kai, what about Bosch? How do you envision that?
I guess in Bosch we also still have different definitions of digital twin, right? So it depends a little bit to who you talk to, which industry. But I like the definition of the Digital Twin Consortium, which is basically exactly what you said, right? So it's basically you know a virtual representation of a physical asset, being able, to use it in the design phase and also during the lifetime of the asset, right? So in whatever way.
I guess in your case, Bosch is exposed across different domains.
Correct.
Right, from power tools all the way to like automotive and aerospace, I don't know, and all the stops in between. So that has to mean different things for different applications, right? Yeah. And I guess Serafeim can give us the maritime technology angle for digital twin.
Yes, what is digital twin? Okay, Also in the maritime technology is quite the same like all the others. First of all, here we have a paradox because the digital twin was actually starting as a marketing term. And now all of us as engineers, we try to figure out and give a definition about digital twin, okay? Also, I am a member of CIMAC, a global organization about combustion engines, and we have a working group exactly for this, only for this matter. So based on my understanding up to now, I would like to have 3 characteristics that make the difference between a digital twin and traditional modeling approach, okay? One is, first of all, when we are talking about digital twin, we must think about model that can be shared. So I can create pipelines with different models in order to create a digital twin of an asset. Second, it is that this model must be capable in order to ingest real-time data, so to actually get the output of the digital twin in parallel with the measurements that we are receiving from the actual asset and compare these two together in order to evaluate the performance of our asset. So the capability to run it in real time is very important. And finally, the digital twins must be based not 100%, but at least to the biggest percentage of them must be machine learning models inside, because the capability that automatically these models can be adapted to the new, to the new situations is fundamental for a digital twin model. Okay, we cannot just develop a standard mathematical model and say that this is a digital twin.
It has to be self-learning and evolving.
Exactly,
right?
exactly that.
Tilemachos, does that track well with what you're seeing being applied for the automotive world?
In my opinion, digital twins are mostly used still in the prototyping phase. They are copies of a physical system. If we stick to our applications in KENOTOM, for example, they are quite precise simulation either of the gearbox that for which we develop the controller, the electronic control unit, or the electric motor, and we use them either to develop some new algorithms and do the first testing there, or even further doing the series production testing of every new software release that we produce before doing the final testing on the vehicle.
Yeah.
This can spare a lot of testing time, and it can also enable the testing before the prototype vehicle exists, and so that when you go to the testing phase, on the final vehicle, you need much less time and you can do it much more efficiently.
And I like that Serafeim brought an interesting dimension to it. Those models ideally have to be shareable. So do you see that, and how does that apply to your value chain? Because you're kind of performing design with the eventual kind of integration in a vehicle, but you're, I guess, a couple of links away from actual automobile manufacturing. So does that model, can it be inherited? Can it be passed downstream to manufacturing somehow?
Well, I would like to mention the definition that I found on Wikipedia about digital twins. There it defines 3 categories. The digital twin prototype, which is what I have discussed, developed before the physical object exists. Then it's the digital twin instance, which starting from the prototype, you can adjust and adapt the model to a real instance of the physical object that you have, feeding it with real-time data. And then it's the digital twin aggregate, where you gather all the data you have for the many instances in order to be able to draw further conclusions. So yes, it's the next step and can be shared to other technologies and giving more added value to the system. But for us, still, it's mainly on the prototype phase.
Yeah, they're definitely very helpful for prototyping and R&D, that's for sure. So hopefully by now we have piqued our audience's interest on the digital twin applications that seem to be in full swing. So I guess going back to you, Mark, can you share some ideally exciting examples of digital twin applications that you're seeing your customers developing that follow the definition you just gave us before?
Yeah, and what we're seeing more and more with customers is they're having to develop a sort of design and use case together, because customers want more now to see the improvement of the product through the life cycle, not just sort of designed out there and then it comes you're sort of redoing something later on. So what they're looking to do is talking with a couple of customers, one in particular who's a compressor manufacturer. So it's a small, fairly inexpensive piece of equipment, but they sell thousands of them. And the customer is looking for ways to do some more effective monitoring on that equipment, but cost of sensors are prohibitive. So it's really difficult to try and provide that equipment with new sensors when the customer doesn't want to pay for it. So a way around that is to use the digital twin that's been developed in prototyping and design, and deploying that as a sort of as a digital twin that they can use on an IoT platform or an edge device. They can then create virtual sensors. They can do what-if scenarios. So what we're seeing is a lot of customers are now starting to do this, where they ship in a digital twin, which is exactly what I was talking about, a virtual representation of that product with the product, so that the customer can either do some monitoring themselves with that digital twin, or it can be used by the OEM to provide additional monitoring services.
Fantastic. And I like your term about virtual sensors, because and I'll be sharing how that applies to agriculture in a moment. But before I do, Kai, any examples that
yeah, maybe what I can add on top what Mark says. So we also have clients building digital twins, for example, for pumps, motors, assets like this, right? So for example, in the oil and gas industry, right? So these are critical assets. So if they fail, you're in big trouble, right? And it's very costly, right? So so a digital twin actually answers a concrete business problem, right? And what I can do on top of it, me as like a pump manufacturer, for example, right? So I can compare my pumps with each other, right? So where are they used, how they are used, and I can go beyond just the digital twin. I can do data management and improve my products over time, right? Based on the digital twin, if you want, right? And you can even think further than that, right? So I mean, that's not what we do currently, but think of metaverse, right? Having a virtual representation of your asset, in a metaverse, right? Where you can train, working with the asset, right? Or where you can have troubleshooting on the asset if you want, right? So I think these are also very exciting scenarios that will come.
And I guess also running things like what-if analysis by applying like different parameters which would not be practical in practice. That might lead to a catastrophic failure if you did it in the actual hardware, but that allows you to kind of do it virtually before you commit it to practice. Awesome. Serafeim, can you share some examples, perhaps kind of guide us through how your product works, because I think that's a prime example what METIS does in the maritime technology space.
First of all, I would like to say that we are still at the early beginning of all this journey, okay? And we are going to see more and more exciting solutions and products in the near future in all the sectors. In the maritime sector, the hot topic in our days is how they are going to reduce the emissions and in parallel keeping the sustainability of all the logistic chain. So we try to contribute to this effort of the maritime sector by offering more and more accurate digital twins of the vessels in order to figure out how to optimize the performance of the vessel and the operation of the vessel in real time. So we know exactly today, with quite good accuracy, what is going to be the total emissions and the total consumption of the next voyage of the vessel, and to propose the optimal speed profile in order to reduce the emissions and the consumption. So yes, we are still at the beginning, but even now we have some very positive results and examples of by applying the digital twin, what is the potential value to our society.
Amazing. So you said predicting the emissions of a certain voyage. So that kind of makes me think that perhaps there are a couple of nice buzzwords that we left behind, like predictive and prescriptive analytics. So are all these now encompassed by what we refer to as a digital twin? Because that is something we can run what-if analysis with, we can issue predictions, and we can kind of apply certain recipes or prescriptions before it happens in the actual physical world.
You are absolutely right, Sotiris. Since I have a very accurate digital twin of an asset, okay, I can, let's say, play with it, okay? So I can use it either to predict, to run some what-if scenarios, either to compare in real time, okay, what is the reaction of my digital twin against what is the actual behavior of my asset, and comparing these two, I can have prediction failures, I can still try to measure the remaining useful life of an asset and all of this, okay? Or I can use my digital twin model in order to run, to feed with data that happened in the past and try to figure out what was wrong, okay? And extract the knowledge in order to see in the future what I should avoid, okay?
Great.
So yes, there are a lot of different ways that you can apply the digital twin.
Which all add value to the solution, right?
Always we are seeking for value to the customers and the end users, of course.
Amazing, amazing. Tilemachos, you mentioned virtual gearboxes, right? And things along those lines. Are there any examples in the realm of automotive which have piqued your interest recently?
One example that impressed me is one example that we are using. Actually, it's not that of the gearbox, it's the digital twin that we use for the electric motor. It may not sound that impressive as an application, but still the impressive thing about this digital twin is its precision. It's really that precise that we can use it not only for just rough debugging and surface testing, but we can really do performance and calibration and performance tests on these digital twins. A few years ago, I would believe that something like this is not possible. Of course, and a little bit coming back to the previous question, in order to do it, you cannot just be based on physical modeling and equations. You do have to measure data and through sensors, and then feed them back to the system and train somehow your digital twin, although in our case this doesn't happen in real time. This happens offline, we gather the data, we correct the digital twin, we train it and fit it as closely as possible to the real example, but the precision in the end that we can reach, it's really impressive.
So we have a number of engineers in the audience and definitely as members of HETIA, so a more technical question. What you described is fairly complex. It's a fairly complex electromechanical system. So how do you go about virtualizing it? Are you using specialized software, like simulation packages out of ANSYS maybe? Or is it like handcrafted code that you develop on C or C++ so that you have a model that works for your purpose?
I don't think that the model is the important thing. For me, when you have to create some digital twin and some simulation model, the first thing you have to think is what exactly has to be simulated. What is the purpose? What you will use the simulation for, so as to decide what has to be simulated in deep detail and what not. Because if you just try to simulate everything in the deepest possible detail, the mechanical, the electrical, the electronic things, then the complexity is so big that you cannot handle it anymore.
Yeah. So maybe resorting to your own code, if it works for the purposes, something you can quickly kind of conjure up and have something going that you can use in your work, right? Rather than trying to emulate everything in the model.
Exactly. You have to do custom simulations. You have to define the purpose. As a tools, we use mostly Simulink still. It's custom-based Simulink with some FPGA additions to simulate the very fast processes like the electric currents of an e-motor, but it's mostly custom-built software.
Okay, that's very cool.
Based on physical models and real-time data that we gather from the system.
Amazing. And I promised to share my own examples from the agri-food supply chain. So the problem that my company is solving has to do with detecting spoilage in stored perishable commodities like wheat and grains and stuff like that. So what we discovered going into this is that there are a lot of large black boxes, like silos with thousands of tons of product that nobody knows what's happening inside, right? So that was, and still is, a significant opportunity for digital twin and IoT applications to kind of make those black boxes transparent again so that our end users can get those models and they can make day-to-day decisions, such as, do I need to sell this product because it's about to go bad? Do I need to use energy in order to ventilate it so that I have less insects eating my harvest and stuff like that? So it's, what we ended up doing is we're using something you're very familiar with, I'm sure, computational fluid dynamics. So we adapted it to modeling the thermodynamic effects on stored commodities. We feed that with sensors, with real-time data. So there we have a digital twin that a farmer can use in order to make those day-to-day decisions. And basically, looking at their silo, they don't see a black box anymore. They see something which is live. And we can, if we have time, we can speak about UIs and the UI UX angle of it. We ended up kind of using something that they're very familiar with, like a heat map of their silo, so that they know which are the hot spots where products start spoiling and stuff like that. So again, different applications, the same theme, but different ways to kind of add value and derive predictive and prescriptive analysis. So the next round is going to be on business models. You said something in Serafeim, and I repeat it again. So a shareable model that can be used for many purposes. That also kind of resonates with other ideas on how you can monetize it, right? What is the business model behind it? So I think I'm going to be starting by you in this round, Serafeim. So is your client aware that they are using and conscious that they're using a digital twin solution? Are they prepared to pay extra for it? Or is it just something they use in the course of a complete and comprehensive solution that I don't know if your marketing prefers to use that term or not. So how does that work?
Of course, the end user is always looking to have a comprehensive solution, okay? He is looking to find answers to his problems. And on the other hand, as you mentioned before, since more and more the decisions that we are making in our business and in our daily life will depend on digital twins, we must find out the way that we must ensure this transparency that you mentioned, okay? So even if the end user is looking just to get a solid solution for his problem, he must have the knowledge and understand what is behind it, what means digital twin, and etc. And this is very important, okay? Now, regarding the business models, definitely here we are going to see a new business coming up because of that. Okay, what I'm talking about. Since the last years, I'm in a lot of discussion with huge makers like MAN or Varcela and other smaller makers that they offer their products out in the market. And all of them, they try to also now develop some digital services, okay, and create their own cloud. But at the end of the day, it is not possible for the end user to log into different cloud systems in order to solve his business problems, okay? So all these makers, in the same way that they are selling their products, they must start selling their digital twins of the products. Okay? And this must be shared, so this must be somehow easily to be part of another solution that try to give a business answer to the end user.
So eventually then your clients, the licensors of your digital twin technology, do not necessarily have to be shipping companies or ship owner companies. They can be other stakeholders in the supply chain. Is this what you're angling for? Or?
Yeah, of course, we are talking about giving an added value to the entire ecosystem here, okay? So, but I would like just to clarify what I try to ask, to say to you, that definitely there are a lot of companies like ours, okay, that they try to integrate and give a solution to the customer. So for all these companies, it will be a great benefit if we could have access to digital twin of the various assets. Because at the end you have a vessel, and the vessel you have thousands of different assets on board. Okay.
Yeah. Fantastic. Yeah. Tilemachos, kind of a different question for you. Are we going towards a future where trips to the car mechanic will be a thing of the past, because we have everything virtualized and we can control our vehicles and their maintenance in that fashion, or what do you think?
Well, in order to avoid the trip to the car repair shop, then the digital twin will have to repair the car as well, so probably not possible.
I mean, kind of an algorithm doing it for us remotely, right?
No, the repair cannot be done by the algorithm, but on the other hand, the predictive maintenance, which is the key word, so having digital models that will predict the lifetime of the various components of the vehicle, of course, this can increase the productivity and the planning of the car repair shops. You don't have to visit, you will not have to visit the car repair shop once in a year, but you probably have to you will be able to extend this time interval and to go just when you know that some component is going to be bad in the next days. And not only that, it enable a better planning and more efficient planning for you and for your visits to the car repair shop, but it will also enable the car repair shops to make more efficient their work. They can plan ahead, but spare parts are missing. They can reduce the storage for spare parts, for example. Then can plan the time they want to repair for various parts. So everything will become much more efficient.
More streamlined.
And this time will be drastically reduced.
Yeah, okay. I'll subscribe to that for now. So yeah, we're coming up on time. So we still have a couple of questions for you guys. So first of all, Mark, any thoughts on business models? Is there, for instance, such thing as a digital twin as a service coming up, or what should we anticipate?
I mean, digital twin as a service is something that's been around for a while anyway, in terms of OEMs using machine learning to understand the behavior of a gas turbine or a pump or a compressor, but they are just purely focused on the sensor data that's available.
Yeah.
So predictive analytics, prescriptive maintenance, as you were saying, trying to identify these things occurring very early on in their development to try and get in there when the problem's small and easy to deal with. That's something that's been going on for a long time. Other sort of business use cases or ways to market, I guess, are troubleshooting, using digital twins for troubleshooting, system configuration. Also, to sort of aid prescriptive maintenance and predictive maintenance as well around, there are limitations with what you can do with sensor data, and you are limited by that sensor data and understanding the known failures of that piece of equipment. So what we can do is we can supplement those machine learning models, those digital twins, with physics simulation information to create a hybrid digital twin that then allows you to do the sort of what-if scenarios, because we can add those virtual sensors. We can be more accurate about the remaining useful life estimation and so on. So it helps us to, in sort of both ways, to say, if I'm overstressing this piece of equipment, how long have I got before I need to sort of think about maintaining it or having some inspection? And also, if you're only sort of running a piece of equipment at 50% load, how does that impact that equipment? And can I push those maintenance intervals out and stop doing it on a time-only basis? So there's a number of sort of value chains there.
Awesome, thank you. So Kai, I think we're going to be wrapping this up with you. So yours is a job title that I really envy, Technology Evangelist. So I guess we'll leave it to you then to kind of guide us to the future. So what lies ahead? What haven't we seen yet, which you guys haven't stopped?
Yeah, I mean, I think it was already mentioned, right? So I mean, so first of all, we are still sort of at the beginning, right? So with digital twins, right? We see that using them on an asset level, right? But I mean, the world is definitely more complex, right? So if I think of an oil field or of a ship, I have many different components which by itself can be represented with digital twins, and I need to compile it together, right? And in order for this to work, we need standards, we need open source, right? And we basically, I mean, we use it, I would say, as a tool, if you want, to solve business problems, right? So I mean, And the business problem is really the key word for me, really, right? So, because, I mean, in the end, you know, depending on how you look at it, right, it's like, you know, digital twin as a service, right? So you cannot sell a digital twin as a service, really, right? You enable a service with a digital twin, right? And this is, you know, what we have to really investigate more, where this has to go, right? And we have one initiative that I would like to maybe just quickly mention. It's called Digital Auto. So it's, you know, driven by Bosch, but it's not just us, also other, you know, stakeholders participate. And what we're trying to do there is basically in the context of software-defined vehicles, which is now, you know, a hot topic, right? We build up basically a virtual representation of a car with all kinds of interfaces, you know, how you can talk to the, you know, wiper, ECU, and so on, right? And you can then also simulate this, right? And you can also, in this case, not just, you know, simulate for your own purposes, but also for user trials, for example, right? Do you like this, right? And then you can continue.
Fantastic, I like it. So I guess that's a wrap for this panel. Thank you for attending. I hope everybody's a bit wiser on digital twins after listening to our excellent panelists. Good luck and enjoy the rest of the day. Thank you.